This tiny gray box costs more than a Lamborghini, takes 4 years to get, and right now, it's deciding who wins the entire AI race. And it doesn't have a single chip inside. I'm serious. Everyone thinks AI is about ChatGPT and NVIDIA. They're all wrong. The real war is being fought over a piece of 1880s technology sitting in a swamp in New Jersey. And because of it, an acre of mud just sold for $615 million. In the next few minutes, I'm going to show you how an air conditioning company just beat almost every software company on the planet, why the 5 biggest tech giants are dumping $700 billion into steel and cement, and why the smartest venture capitalists on earth are completely locked out of the biggest opportunity of our lifetime. Stick around, because once you see what's really powering AI, you'll never look at this industry the same way again. Let's get into it. Let's start with a question that sounds stupid. Where physically is the internet? Maybe you've seen the memes, the cloud is just someone else's computer. Well, that's true. In fact, a big chunk of the financial internet, the part that moves money all over the world, physically lives in Secaucus, New Jersey. It's a swamp. And until not that long ago, Secaucus was the largest pig farm in America. 250,000 pigs at its peak, outnumbering the humans 16-1, eating New York City's restaurant waste. The trains rolling past used to shut their windows against the smell. But today, the pigs are gone. In their place, fortress data centers. And the town is doing the exact same job it did in 1940, taking in what New York produces and metabolizing it. It used to turn food scraps into bacon. Now it turns trade orders into money. That is the cloud. It was never a cloud, it's a concrete box in a swamp bolted to a power grid that was designed for a world that no longer exists. And the boxes being built now are a different species. A single hyperscale AI building needs around 20,000 tons of steel. The skeleton weighs as much as 2 Eiffel Towers. America will need roughly 1 million tons of cement by 2028 just for these facilities. One rack of NVIDIA's latest chips draws 100 kilowatts, and if the cooling fails, you have about 75 seconds before the hardware starts destroying itself. These are industrial plants. Jensen Huang's own phrase for them is AI factories, and he is being literal. Now, put the money against the physics. Google is spending around $180 billion this year, nearly double last year. Amazon about $200 billion. Add Microsoft, Meta, and Oracle, and you get that $700 billion figure, committed in a single year to buildings. But the equipment those buildings need is on a multi-year waiting list. Power transformers, 2.5 years on average, up to 4 for the largest. High voltage circuit breakers, 3 years. Even the diesel backup generators run 2 years. In the biggest markets, just getting permission to plug into the grid takes around 4 to 7 years. In Northern Virginia, the utility literally paused new connections. So, the scarce thing in AI is no longer intelligence or chips or even money. It is plain old power. Which is why data center vacancy in North America just hit 1.4%, the lowest ever recorded. This is why 3/4 of everything under construction is already leased years before it opens, and why an acre of swamp lawn can sell for $6 million an acre. The constraint on artificial intelligence and all the hot startups that come with it is really just plumbing. And so if plumbing is the bottleneck, who is getting rich? Meet Comfort Systems. It is a company from Houston that installs heating, cooling, and electrical systems. It has no AI product, no VC funding, no model, and definitely no API. It is, in the most literal sense, an air conditioning contractor. Last year, its revenue grew about 30% to $9 billion. Its earnings per share grew 98%. Its order backlog nearly doubled to almost $12 billion. They've essentially already sold the next few years of work. Those are numbers a hot software company would brag about, produced by, well, an air conditioning contractor. Comfort System isn't alone either. It is part of a cohort, and the whole cohort kind of looks like this. EMCOR, an electrical and mechanical contractor, watched its data center backlog roughly double to a record. Vertiv, which builds the power and cooling guts of these facilities and also co-engineers the thermal systems for NVIDIA's newest chips, reported orders up 252% in a single stretch as rack densities exploded. Caterpillar, yes, Caterpillar is doubling output of the giant engines that back up these buildings. Quanta builds the grid connections. Eaton just paid $9.5 billion for a thermal management business. And behind all of them sit the power companies. Constellation, Vistra, Tallinn, suddenly the most strategically important firms in technology. Think about what the market scoreboard looked like in the 2010s. The best performers were software, asset-light, infinitely scalable, gross margins in the 80%. The scoreboard of the mid-2020 has HVAC installers near the top. Perhaps the VC pick and shovel cliché finally came true in the most literal way possible. So, if this is where the value is pooling, who funded it? You may have heard of a company called Crusoe. They started out capturing waste gas from oil fields to power computing and pivoted into building AI data centers. They are the ones physically constructing the first campus of Stargate, the giant OpenAI infrastructure project in Abilene, Texas. Founders Fund backed them, NVIDIA backed them, and tons of other VCs. Roughly $4 billion of venture money raised across the company's entire life. A genuine VC success story. Now look at the financing of that one Texas campus. $11.6 billion from OpenAI, most of it debt, and a lot of it from Blue Owl, a private credit firm. So let's confirm. One building required nearly 3 times more capital than every venture round in the company's history combined. The VC equity everyone celebrates is a thin sliver riding on top of a mountain of debt. The venture capitalists own the story, but it looks like the credit funds own the asset. And that pattern is now the whole industry. These buildings are financed like pipelines and toll roads, project debt, private credit, special purpose vehicles. The names writing the biggest checks in AI infrastructure are Blue Owl, Apollo, Brookfield, and sovereign wealth funds. Even the hyperscalers themselves have flipped. They issued $121 billion of bonds last year and, for the first time, hold more debt than cash. In fact, Barclays thinks that Meta's free cash flow drops around 90% this year. They believe the richest companies on Earth are just going to keep borrowing to build. But strangely, in 2024, while AI's hunger for electricity was exploding, global venture funding for energy startups fell to a 4-year low. Demand for power? Straight up. Venture money for power? Down. That's weird. The single biggest capital need of the AI era, and the startup industry's money walked the other way, piling instead into a handful of AI labs big enough to absorb it. Sadly for VCs, this is just structure, not stupidity or missing an opportunity. When it comes to opportunities like this, VCs are, for the most part, locked out. So here are the 4 reasons why venture capital cannot own the steel, and each one is a wall. The first is time. A venture fund has to return money in about 10 years. A substation, a campus, a reactor is a 30 to 40-year asset. You cannot hold it long enough to be right about it. Second, the shape of the returns. Venture math needs one investment that pays 100x to carry all the failures. A transformer factory or a fully leased data center produces utility returns. 8%, 10%, dependable, contracted, boring. There's no fund returner hiding in a cooling loop. Recently, I made a video about lean AI startups breaking venture because they no longer need the money. This is the same crisis from the opposite direction. The software companies need too little capital, the physical layer needs too much. Third is the check size. A single campus now costs more than most entire venture funds, and the equity slice on top of these projects gets priced by infrastructure investors at infrastructure multiples. There's no story you can mark up 20x for your LPs. Fourth is the skill. Underwriting a grid connection queue, water rights, and construction contracts is a real profession. The people who can do it, Brookfield and Apollo, for example, are enormous companies with thousands of associates running the numbers. It is simply a different job. Now, to be fair, venture does have a seat at this table. We already mentioned Founders Fund owns a slice of Crusoe, though the secondary market currently prices that at a very heroic multiple with billions of debt stacked above the common. You can own the software wrapped around the steel, grid optimization, interconnection tooling, power management. And you can own the technology bets that might one day make the steel obsolete. Fusion, small modular reactors, radically distributed energy. Those are venture-shaped because they are binary bets on an invention, and there is a lot of capital there too. Just the other week, European Proxima Fusion raised 411 million euros, marking the largest ever private investment in European fusion with strategic investors including Google. So the honest summary is this: venture can own the software around the steel and the moonshot against the steel, but it cannot own the steel. Which leaves a somewhat uncomfortable question hanging over the whole industry. If the durable value of the AI era pulls in power, land, and construction, asset classes any pension fund could have bought through a boring infrastructure vehicle, what exactly is the startup economy's claim on the biggest technology boom ever recorded? The labs at the top and the application layer at the surface. Everything in between belongs to people in hard hats, in people who price debt. But before you conclude that the future belongs entirely to electricians, let me add one thing. Bottlenecks attract capital, and capital dissolves bottlenecks. Transformer factories are being expanded right now. Every stat in this video is an invitation for someone to build supply. And we have run this exact movie before. In 2000, the equivalent boom was fiber optic cable. Companies spent fortunes wiring the planet for an internet that was absolutely real. Almost all of them went bankrupt anyway. There was too much fiber, too soon, and the value went to whoever bought it later for 10 cents on the dollar. Today's record backlogs are tomorrow's overcapacity if demand so much as pauses. There's also a nastier version of that risk, and Jim Chanos, the short seller who caught Enron, has been pointing at it specifically. The buildings last 30 years, but the hardware inside them is obsolete every 2 or 3 chip generations. A 10-year-old air-cooled data center is already functionally a stranded asset. The landlords may be depreciating their building far slower than physics depreciates them. And all of it leans on one assumption, that compute demand keeps compounding. If model efficiency keeps improving the way it has, or the application layer disappoints, those multi-year backlogs can unwind fast, and the entire industry cohort derates altogether. Every technology boom eventually touches the ground. The railways touched it as steel track. The internet touched it as fiber in the dirt. AI is touching it as transformers, water rights, and concrete poured over old pig farms in New Jersey. And every time, the same thing happens. The glamour is at the top of the stack, while the money pools at the bottom with whoever owns the physical, permitted, or scarce thing that everyone above them needs. The paper that started all of this was called Attention is All You Need. 8 years later and $700 billion later, it turns out attention was never quite all you need. You also need a gray metal box, a 4-year waiting list, and a place to plug it in. Thank you for watching. Don't forget to subscribe, and I'll see you in the next one.